Hello, Mahdi, and welcome to my lesson. Today we're going to do GCSE Maths. But first of all, before we look at any maths, I'd like to do a quick thought experiment. So while I play this audio, I would like you to close your eyes. Now, the audio is 2 minutes long, though it might feel like 10 minutes. But here we go. So close your eyes while I play this. Are you ready?
Yeah.
The sky is red. You remember when you were 3 or 4, looking up at the sky with amazement, and you asked your parents, why is the sky red? They do not seem to know why the sky is red. They just said the sky has always been red, and that God made it red. You have contemplated why the sky is red many, many times in your mind. Now, you just accept that the sky is, and will always be, red. Right now, shut your eyes. In your mind's eye, you see white clouds set against a bright red sky. Every time you see a movie, the director never misses an opportunity to remind you the sky is red. In every scene, the sky is bright red. The screenwriters write screenplays talking about the red sky. Every TV show you watch, no matter what the subject is, always reinforces the sky is bright red. It doesn't matter if the television show is a sitcom, sports-related or home and garden TV, the sky is always red. Every song you hear about a sky, it is always red. Every tweet you see reminds you the sky is red. Every Instagram and Facebook post tell you the sky is red. You think back and remember that every book talks about the sky being bright red. You recall that NASA explains the sky is red because the reflection of red light from the sun. Even the internet agrees the sky has been red for over 100 million years. This means the dinosaurs saw the sky as red when they roamed the earth. Every newspaper article, every commercial, every billboard, every concert, every church service all say the sky is red. 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 The sky is red.
Okay. So thank you for listening to that audio recording. So now I want to get the question up. So we've listened to the recording. I'm going to share my entire screen. And here we go. Hopefully you'll be able to see the document now. So I want to go through this document. So this is exercise 1. So it was a quick thought.
I can't see the screen. I think it's still loading.
Okay, so it might be still loading. So this links into exercise 1 here.
Okay, I can see it now.
Okay, brilliant. So exercise 1. So it was an exercise in thought. It was a thought exercise. So the question here, does it automatically change the color of the sky if 8 billion people believe the sky is red and believe it to be red every day of their lives? Have they actually made it red, even just a little bit? Is what we perceive actually true? So I'd like you to... What do you think this question is getting at? So it's about perception, isn't it?
Yeah.
So essentially, if you... Well, again, this links into... What do you think this links into, making people believe that the sky is red? When we... So it's about deception, isn't it?
Oh, yeah.
Mm-hmm.
Yeah.
And so it was just a quick thought experiment. So I would like you to also try to answer this question here. So does it automatically change the color of the sky if 8 billion people believe the sky is red and believe it to be red every day?
No.
Okay. Though 8 billion people believe the sky is red, it's going to be the sky is actually blue. Okay, so that's fine. So it's about perception here. And this links into one of our previous lessons, how people perceive us as well.
Yes.
So it's important to, I think it's very important to do these thought exercises as well. So exercise 2. So could you read out the text and try to answer the questions for me?
Okay. It is highly possible that you either work as a member of one or more teams or groups currently or have in the past. You presumably belong to a group or groups outside of school as well. Briefly consider these groupings and jot down your thoughts on the following questions.
Okay, so I'm just going to let you tell me. So instead of writing down, I'm going to ask you which group at school and elsewhere do you participate in?
Um,
So was it a
could you
football?
explain? Could you explain the question?
Yeah, the question. I just want to. It's a simple question. It's just, do you belong to any groups at school? Do you belong to any groups outside of school?
Oh, okay. So,
Hmm.
um, in school we belong to like form groups.
Okay, so it's year 10.
Yeah.
Okay, so form groups. Is that for your group? Is that for your class or for the whole year?
Just like my class.
Your class. Okay.
Yeah.
So you have that each year, don't you? So year 8, year 9, year 10,
Yeah.
etc. And okay, so that would be a group. Now, that's a group in school. So it's a group that you're involved in school. And do you have a form, like a class rep?
Um, um, it's not really like a class rep, but there are some people that just for like the whole year they represent the whole year and to share their thoughts with the whole school.
And would that be a role you would be interested in?
Um, Not really.
Okay. And tell me, do you belong to any groups outside of school? Do you participate in any groups outside of school?
Yeah, with my friends.
Okay. And is it a sport? Is it sports related, or do you um is it playing games, football?
Yeah,
Okay.
sports.
And okay, so I think I've answered the first question. So the next question: could you classify these groups as formal or informal? So you mentioned about your form,
Yeah,
uh, your form class in school. Would that be a formal or informal group?
formal.
Could you elaborate a little bit?
So I would say we have to be more organized and like respectful and follow more rules.
You say rules. Is there a code that you need to follow?
Yeah, so we have to dress a certain way, and we also have to speak a certain way.
So there's expectations, and if you don't follow those expectations, is there disciplinary action taken
Yeah,
and potential suspension
yeah.
or withdrawal? Okay, so so what about this? Your friends. So you have a group outside of school, and that you participate in with your friends. Is that an informal or formal group?
I would say more informal.
Okay, and do you want to elaborate a bit more?
I think it's because we have more freedom and we don't really have to follow other people's rules.
Okay, so um, but there's social norms, isn't there? So
Yeah,
in a sense, although it's not as strict. Is that what you're trying to say? There's no strict rules, though
mhm,
you have an awareness of social norms. Yeah.
yeah, yeah.
Okay, thank you. And what about the next question then? What part do these groups play in your student life, in your opinion? So you've mentioned two groups so far. What part do these play in your student life, in your opinion?
So I would say the form group would like the groups um
What function do they play?
so they they help us the form groups helps us stay prepared for the school year, and if we need anything then we would ask the form teacher.
Okay, okay. Interesting, very interesting. Thank you. And what about your friends, your friendship group? What role does
um,
that play in your student life? Are they friends at school or friends in your neighborhood?
Friends in school.
Okay, so school friends, and how important is it is it to interact with your school friends outside of school?
um, I would say it's important because I feel like if you want to have a good social life, then you have to like talk to your friends and you have to be able to make friends.
Yeah, thank you very much. Okay, so moving on. Well done, Mahdi. Okay, so we're going to now look at what the function of we're going to look at numbers. Okay, so you know what data is, data,
Yeah,
statistics, etc. So, for
yeah,
example, we can use data, and the our world in data.org has obviously used numbers here to estimate the size of the world population over the last 12,000 years. Okay, so as you can see, in 2019 there were 7.7 billion people on planet Earth. Now, if you go back in time, you'll see a steady decline in the world population. Now, the thing I want to point out here is that the table of population is really only reliable to us when it begins around the 1900s, and much of the early numbers are rank speculation. So 10,000 BCE, 8,000 BCE. I mean, you got 4 million in 10,000 BCE. What do you think I mean by rank speculation?
so it's more of an estimate earlier in the early numbers.
Okay, so they are they're not reliable as such. Is that what that means? They're not
Yeah.
okay. They're not really reliable. Okay, so just brilliant stuff. Okay, moving on then. We're going to look a bit more in this document about we're going to apply it to the universe, our knowledge of the universe. So I just want this is just a reading activity, really. Also, I want to share some amazing facts that I've dug up. Um, that might help supplement your knowledge of the universe. So if you could just read these out and see what role numbers play in our understanding of the universe and our knowledge of the universe. So if you just list them off for me. So beginning at A.
Okay. According to the best estimates of astronomers, 275 million new stars are born every single day. B. Olympus Mons on Mars is about 3 times the height of Mount Everest. C. There are up to 400 billion stars in the Milky Way galaxy and up to 50 billion planets. D. The universe spans a diameter of over 150 billion light years. E. There could be up to 500 million planets in our galaxy capable of supporting life. F. There are probably more than 170 billion galaxies in the observable universe.
And then to the right, thank you. And then to the right, you have an image there. If you hold a grain of sand up, the area of sky it covers contains as many as 10,000 galaxies. Isn't that amazing?
Yeah.
That is extraordinary. Okay, so now we're going to start. Well, I'm going to start with. We're going to move on now to the maths, but I want to do this little warm up activity. So, exercise 4. You could work out these for me. So they're all as a list. So starting off with 145 plus 60. Sorry, 145 plus 654 plus 18. Did you bring your calculator today?
Um. Yeah, I have a calculator.
Okay, that's going to be helpful. So
Yeah.
this is just a warm up exercise, really.
Okay. Okay. The first one is 817.
Okay, so I'm going to just try. So 817. Okay,
Yeah.
and then the next one.
The second one is -2.
How did you get -2? So we've got 8 plus -10. What did you do there?
Um. So, when you're in negative numbers, when you add
Mm-hmm.
the number, the number gets the number gets smaller, but it's not actually smaller. It's bigger because it's closer to 0.
So the plus and the minus becomes a minus. So it's as if you're saying 8 minus 10. Is that what you're saying? Which gives us minus 2?
Yeah.
Okay.
Yeah.
Okay, thank you. Next one. So we've got 2 minuses here.
That's going to make a plus, so...
Okay. So 6 minus 5.
Oh, 1?
6 minus 5 becomes... Does that not become... did you not say that becomes a... So what did the 2 minuses become?
Two negative... if there's 2 negatives, then it becomes a positive number.
Yes. So So in that case, it will be 6 plus 5. Okay, so that those two transform into a positive. So it'll actually, wouldn't it be 11 then?
Yeah.
Okay. And you don't need to show the plus sign for the positive. It's going to be invisible there. Okay, now this next one, minus 9 multiplied by 6. So we've got a negative and a positive. We've got minus 5 multiplied by, well, that'll be a positive 6. What would that?
Negative 54.
Okay. Negative 54. And then the next one, let me scroll down a bit. Minus 6 divided by minus 30 divided by minus 6. Again, there's 2 negatives.
5.
Sorry?
5.
Tell me how you got 5.
So, if you divide 30 by 6, it's 5. But because there's 2 negatives, it'd be a positive number.
Okay, and then the next one, 10 minus 5 multiplied by 2. So what?
That would be 0.
Right. How did you get 0? What did you do what did you do first of all?
So first I did 5 times 2.
So why did you do that first?
Because there's a process called BIDMAS.
Explain that to me. BIDMAS.
So in an equation like this, you would do 5 times 2 first.
Okay.
Because
multiplication. So
yeah.
That's an acronym for different. So can you explain the acronym to me? So it's brackets, isn't it? BIDMAS. Yeah. So brackets.
Brackets, indices, division, multiplication, addition, and subtraction.
Brilliant. Well done. Okay, and the next one.
That would be 13.
Round 12.83 to that should be to 1 decimal place. To 1 decimal place, so 1 decimal.
Oh, okay.
So what would that be?
12.9.
Brilliant stuff. 12.9. Well done. Well done indeed. You did very well there. All correct. So I'm going to come back. Okay, hello. You can. Okay. So what I'd like to do, weren't we looking at triangles in the previous lesson?
Yeah, trigonometry.
We were looking at trigonometry, but on IXL they've got a section, and I'm still sharing my screen here. It's triangles and trigonometry. Can we have a go at the Pythagoras Theorem before we move on? Can we take it in stages?
Yeah.
Okay, so Pythagoras Theorem, triangles and trigonometry. There's a whole section on this. Let's try to master this Pythagoras Theorem. Would you like to see the example first of all, before you do the question, or are you happy enough to have a go at the question?
I'd like to see the example.
Okay. So in the example, so the Pythagoras Theorem is a squared plus b squared equals c squared, where a and b are the lengths of the legs and c is the length of the hypotenuse Do you see C there?
Yeah.
So it's always opposite the right angle triangle. This is called Pythagoras' theorem. Do you want to write that down? Pythagoras' theorem, a squared
Okay.
plus b squared equals c squared. So Pythagoras was an ancient Greek mathematician who's gone down in history. This is borrowed from him. So Pythagoras' theorem, a squared plus b squared equals c squared.
Yeah, I've written it down.
Okay, so in this question here, they wanted us to find out, what is the length of the hypotenuse? So c equals blank centimeters. So you do it in stages, okay? So Pythagoras' theorem with a equals 8. Do you see 8 there? So the
Yeah.
adjunct leg, and then b is the other adjunct leg. So that's 6. So 8 squared plus 6 squared equals c squared, and that is c squared is the hypotenuse. So the square, well, obviously that then the next stage is they actually square 8 times 8, and that would give you 64. Yeah.
Yeah.
Plus 6 times 6, which would give you 36, and that equals c squared. And then they added it, so there's there's the addition there. So 64 plus 36, which equals 100. So they added those together. Then what you need to do, take the square root of both sides. Okay?
Okay, yeah.
And then you simplify it down, and it's 10. So the length of the hypotenuse is 10 centimeters. So let's have a go at this. Did you write any of that down there?
I'm going to write it down now. Okay, I've written it down.
We'll move on to the practice questions. So this first one then, they actually want us to now this one here is slightly different because we know what the equation is, what the theorem looks like for the hypotenuse if we want to find out the hypotenuse. But here we have one of the adjunct legs. So what do you think? How would you go about this one? Do you know? Yep, go ahead. Mm-hmm.
So would you do yeah, I'm not sure.
So it would be c squared, so we know it's 20 squared, minus b squared, which is 12 squared, equals a squared.
A squared, yeah.
So you subtract. Try. You can still try to work it out there. Do you want to? Are you able to? I wonder. Are you able to draw on that board for me? What if I did this?
Which board?
Just so I can see your working out. So if I did this, I copy and paste this onto the, the cheerful, the whiteboard.
Yeah.
Let me see. Am I able to paste? Let me try something here. Mahdi. I'm just going to save that picture and try to paste it into this so that you can draw. You can show. you can show me your working out. Okay, does that sound like a good idea? I think that might help.
Yeah.
That would help us here. So, hope this internet isn't lagging. It is a little bit. So snipping. Going to take a snipping of this and then save it. Save it in images. Images. Capture 1.1. And I'm going to put it into this whiteboard for you. So pictures. Please work. I hope this. I haven't done this before, so this is the first. Oh, it worked. Do you see it?
Yeah. Yeah, I see it.
Okay, so try. You can take over.
Okay. So I would do C. Actually. Oh. Okay.
So we've got the hypotenuse, c squared.
C squared negative B square equals A square.
Mm-hmm.
And then what I would do is I would do
Well, you know the value.
12.
Yes, you know the values
Oh,
of
so
c squared is
12,
okay. Go ahead. Yeah. No, that's
12
no.
squared.
12 squared isn't for the c squared. 12 c squared is the
Oh,
hypotenuse.
okay,
Mm-hmm.
okay. So 20 squared and then I would do 20 squared negative 12 squared.
Mm-hmm. So 12 squared minus, or sorry, 20 squared minus 12 squared. So yep, equals a squared.
Yeah,
Mm-hmm. So do you want to? Are you able to then find out what 20 squared is and what 12 squared is, and then
yeah.
okay.
So 400
Mm-hmm.
take away 144 equals a square. Yeah. So then I would take away both of the numbers.
Mm-hmm.
And that's 256
Mm-hmm.
equals a square.
Okay, and then
And then I would find the square root of the number. And then equals b squared, and then that would be.
Can I ask you, are you using a scientific calculator?
No, I'm just using a normal calculator.
Are you able to? Can I just see it on the screen? Can I see it?
Just the phone's calculator.
Oh, okay.
Yeah.
All right.
I think I can make it scientific if I turn it sideways. Yeah. And that would be 16.
Okay, so you've worked out the square root of 256, and you've got 16. So do
Yeah.
you want to see? Let's have a look. Thank you very much for doing that, Mahdi. That was great work. Now let's see how we did. So 16 kilometers.
Yeah.
Okay. Well done. That's right. Do you want to do the same with this one? This next one. Oh, sorry. Yes,
Yeah.
yes, you were right there. Now this next one, so you got points there. Well done. Pythagoras Theorem. You got points, so well done. 10 for that. Okay, so what I'm going to do again is I'm going to take a snipping. And I'm going to get you to do the same thing again. Capture 1.2. Put it into the images. So you should be able to do the same thing again. Okay?
Yeah. Okay.
Now it's a similar sort of question here because we're looking for the adjunct leg. We're not looking for the value of the hypotenuse here. So it's the same sort of process. So
I can't write on the screen right now because you're still sharing the screen.
okay, yeah. You'll be able to write on it now.
Yeah.
Okay, so the same sort of process again.
Okay, so I would do c squared minus b squared equals a squared.
Mm-hmm.
And then I'll do, actually, yeah, and I would do 6 squared minus 10 squared. And that equals a squared.
Mm-hmm.
And then that'd be 36 minus 100. Yeah, and then equals a squared. And then I think I did something wrong.
Yeah, hold on a second, you did. It's the other way around.
Yeah.
The c squared, that should be 10 squared. Yes, So just swap those around. And
Okay.
well done for noticing that.
And then that, and then I would find. Actually, no, I would take away the number. So that's 64.
Okay.
And then I'd find the square root of that number.
With your scientific calculator?
Yeah. And that equals 8. So that means that A equals
No,
8
yeah, A
millimeters.
equals 8 what? 8 millimeter?
Millimeters.
Okay. So I'm going to now. Well done. Thank you very much, Mahdi. Wow. Wow. So you're making a lot of progress here. So I think. So it's 8 millimeters. Just have to wait for this internet to. Can you see my screen?
Yeah.
8 millimeters. I'm putting it in now. Well done. Super. And I'm going to get you to do another one. Is that okay? Happy
Yeah.
enough? Yep. So same thing again. Snipping. Save as. Capture 1.3. Go to the image and logo, and I'm gonna just open up this next one, and it's uploading. Just have to wait for it. Okay, it's gone over it now. It's actually whoopsie daisy. Has it just gone over it? Oh, hold on a second. What happened there? No, sorry, I don't want that one. I want that one. Sorry, I think that I've made it. Hold on. That's it now. Happy days.
Yeah. Okay. So I'm not sure what I would do on this.
Well, it's exactly the same thing.
So I would do A take away C equals B. So A squared minus C squared equals B squared. Okay. So so A squared take away C squared equals B squared.
Mm-hmm.
So then I would do 8 squared. Okay. variant. Okay, 8 squared.
A squared is a. So a squared is 8 squared, and c squared is 17 squared.
Yeah, I'm just trying to make the number smaller so I don't get confused. Put it like that for now. Okay, so, and then take away 17 squared. Okay, and then that equals e squared. And then I would see what that is. So 8 would be 64. And then
Yeah, so 8 squared is 64, okay.
take away 17 squared. And 17 squared is 289. I think I did something wrong here as well.
It's just a matter of swapping them around here.
Okay.
So the c squared is the hypotenuse, which is
So,
we've worked out that it's the bigger number here. So just take away the
okay.
just swap it around. That's all. The hypotenuse will always be the longest leg.
Okay. So that's 225. And then actually, I wouldn't put 225 there. I'd put 3 squared. And then 225 equals b squared. And then I would find the square root of the number. So then it would be okay. Square root of 225 equals 15.
Put your square roots around the 225.
Yeah, I'm trying to draw the square root symbol, but whenever I go on the pen icon, then the text just disappears.
Okay, right. So what did you get? Sorry, what was the square root of 225?
15
Okay, so
kilometers.
a squared equals good. Okay, thank you. So 15. Let me just put that into the. I'm going to share my screen again. So 15 kilometers. Okay, just have to wait for this internet. Okay, 15. Let's see. Submit. Right. Well done. And one more before we move on to trigonometry. Will we do one
I
more?
can't see the screen right now.
Okay, so I'm just taking another snipping.
Okay.
I'm going to save it as capture 1.3. Save. Oh, yeah, okay. Save and also go into this. Okay, capture 1.3, open it up. What's going on here? Why is it not opening up? Sorry, there's a delay in the internet. What is going on with this? I don't know what's happening here. Any idea what's happened? Frozen?
I'm not sure. On the, you know where it shows the connectivity?
Yeah. Oh, it's back. It's back up again, though.
Yeah.
It's back up again. Oh dear. Oh dear. Well, what we'll do is, I need to find out what's going on. Why is it doing this? I'm sorry. What's going on here? Because it's like I've been disabled. I can't. Oh, here we are. Is that it now?
Yeah.
That's it now. Okay, so I'm going to hide and stop sharing so that you can draw.
Okay. Okay. So a squared plus b squared
Equals c squared.
equals
That's the
b squared.
this is the Pythagorean or the Pythagoras
Yeah.
theorem. This is the one that we looked at the start.
So then it'd be 12 plus. Oh, actually, no.
Squared.
12 squared plus 9 squared and then equals c squared, and then 12 squared is 144.
I don't know what's happened, but there's blank spaces in between 12 and the plus sign and the 9 and the equal sign. Did you?
Oh, that's because that's where I'm writing the squared, so I'm just drawing the squared with the pen.
Maybe just a 2 there, or type 2 instead. Oh, what
Okay.
happened there? Release the text.
Okay, 144 is 12 squared, and then plus 9 squared, which is 81, equals c squared, and then that is 225. And then find the square root of that number. Equals c squared, and then there's 15.
Thank you, Mahdi. Now I'm going, so 15 centimeters, okay? So I am going to now share my screen. 15 centimeters. I'll put it into the box. 15 centimeters. Let's see how we did. Brilliant, good work. Wow, that it really helped, didn't it? Going over that again.
Yeah.
Okay, so yes, hopefully that obviously we'll do more practice with the Pythagoras theorem. Now Can you see IXL again?
No.
You can't see IXL. Okay, so
Okay, I can see it now.
Brilliant. Okay, IXL. So under triangles and trigonometry. Now, I think we need to get an understanding of the difference between sin, cos, and tan. Okay?
Yeah.
Now, before we actually go, before we look at all the other activities. So let's see what this trigonometric ratios. That's what this. So I think what we'll do first is have a look at the example to help us out here because there is a question, but I don't think we'll look at this first. So here we've done a question like this before, didn't we? We've done a question before. So sin d
Yeah.
So learn with an example. So find the sin LD. So simplify your answer and write it as a proper fraction, improper fraction, or whole number. So the sin of a sin of an angle is a right triangle in a right triangle is a ratio. It is the length of the opposite leg. So what do we call? So the opposite divided by the hypotenuse. Okay, so opposite divided by hypotenuse. The opposite leg is the side across from the specified angle on the hypotenuse. Well, that's always going to be direct opposite the right angle. Do you see how it's just? Do you see how the color codes?
Yeah.
We would call the now before we've called that opposite an adjunct, but here they've called it an opposite leg divided by the length of the hypotenuse. The opposite leg is the side across from the specified angle, and the hypotenuse is the side across from the right angle. So the hypotenuse is always the longest leg.
Okay.
So here's the formula. So take the formula. Do you want to read this out to me? Okay. So this is the formula. So read it out to me. So
Okay. So sin D equals opposite divided by hypotenuse, and then that's the definition of sine, equals BC divided by BD. Substitute opposite equals BC and hypotenuse equals BD, equals 56 divided by 65. Plug in BC equals 56 and BD equals 65. So sin equals 56 over 65.
Okay, so that's a fraction. Okay. Write it as a proper fraction, improper fraction, or whole number. Do you want to have a go? So did you write that out, the example there?
No.
Okay, write it out just for reference sake. Write it out.
Okay. Okay.
Okay,
Written.
brilliant. Thank you. I think what. Okay, so the sin of LW. Okay. Now you can write it again. You can write it as a fraction. So do you want to me to take a snipping of this, and you can do the same thing on the whiteboard? You can. Would that work?
Yeah. Yeah.
Okay, so I'm going to save this. Capture capture 1.4. Okay. Go to the whiteboard. Stop sharing. Put the camera on so you can see me, and put the image in. Here we are. So open this up. Right. So now I might have to. Wow, it's too big. I'm trying to. Can I minimize this? How can I? Are you able to adjust the size of it, Mahdi? Could you make it smaller for me? Could you fit it into the
Yeah.
screen or the whiteboard? Good, thanks.
Okay. Is that okay?
Yeah, I can see it. Yeah.
Okay. Yeah. Not sure what's happening. Okay. So
Sin equals. So it's sin W equals opposite divided by hypotenuse, isn't it? What we need to
yeah.
find the. Okay, so is that the? Are we going with that one then? Will we try?
What would be opposite?
See, opposites adjunct. So the opposite. Find the sign of LW. See, for this one, opposite is adjunct, and hypotenuse is always the longest leg. So let me just see. Sin W. Did you? So you wrote out the. We've got 55. So it's W. Find this in it. Let me go back. So this is sin W. The adjuncts are beside the right angle. There's two in this case. So we know what the hypotenuse is, don't we? 73.
Yeah. Yeah.
Sorry, let's go back to that example again. I'm going to just share my screen one more time. Oh, what's it? It's lagging. I'm going to share my screen. I want to show you the example again, because that was sin. So it's the one going so x. Let me just see. So do you see here, find the sign of LD? LD's on top there. So they had all of the lengths measured out. Do you see that? So in this, what are we finding W? So what did they go up? What did they go and do? In this, so D, so LD. Okay, the opposite was the one that was adjacent to the D, and the hypotenuse was the longest one. So you're going to go with the one that's adjacent to the D or to the W. Okay, so hold on a second. If that makes.
So how would I know which one is adjacent?
This one here. Hold on. Let me go back to the tutorful. It's 48. It's the adjacent one, the opposite, and then so if you're following their logic, isn't it? So the opposite leg.
Okay.
Does that make sense? Try it anyway, and I'm sure we'll find out eventually. So
Okay.
so LW, so
Okay.
adjacent,
So
and
Okay. So I would do
Sin W.
sin W, and then it would be opposite and hypotenuse
Mm-hmm.
equals XW.
Yeah.
Okay, and
Because
then
that's the adjacent, isn't it? And then the hypotenuse is going to be the
hypotenuse is V to W. That equals 48 over 73. Is it correct so far?
fraction 48 over 73.
Yeah.
Hold on, I'm going to check. 48 over 73. So did you follow all all of the processes?
Yeah.
Now, will this let us do it as a fraction? That's what I'm wondering. 48 over 73. Now this is obviously going to show us well, let's see, 48 over 73. Nearly. Hold on. So it was actually 50. We got the 73 right. It was 55. Hold on. I thought. Sorry, 2 seconds. So we got the hypotenuse part of it right. Hold on. It was the opposite part that we got.
Yeah, I can't see the screen.
Oh, sorry. Oopsie daisy.
Okay.
Okay, so you should
Can
be
see
able
it
to.
now.
Now, hold on a second. It was actually the 55. Now, I thought that obviously this is let me see. Oh right, hold on. It's opposite the. It's the one. Do you see that? I'm sorry. I misunderstood that. It's opposite is not the same here as adjacent. See in this example here, x. Do you see the one that's opposite the x here? It's
Okay.
opposite,
Yeah, I see it.
but the hypotenuse. Well, we always knew what the hypotenuse was, but here, right now we know. Do we understand now?
Yeah.
Right, we'll keep going, will we? It's
Yeah.
important. Well, again, we learn from our mistakes, and I thought that it was the adjacent one, but that's okay. We're allowed to make we're learning here. We're learning together.
Yeah.
So it's capture 1.5, and I'm going to go back to the screen. I'm going to delete all of this because I think this is all getting in the way, of you being able to write
Yeah.
or type and everything. Could you delete all of that? Can you help me delete everything?
You're still sharing the screen.
Okay, so I'm just deleting everything, all your twos, and I'm going to put the image in. So hopefully now,
Okay.
Mahdi, I think we've got the hang of it now, don't we? We know where we need to go with this. So it's fitted nicely into the
Yeah.
whiteboard. So now what? So the tan C. So what can you? What do we? So this is a different one now. This is tan. This isn't sin. Does this mean that do we follow the same processes? Do you want to try it out? Tan C equals opposite divided by hypotenuse. So opposite would be the. Okay, I'll let you do it.
So should I do it should I do it the same as how I did the other one?
I would say so. The reason being, that was the only that was the only example they showed us. So just try it anyway, and see what because it'll obviously show us the right answer, won't it, afterwards? But they've showed us that example, and that was the only example they gave us. So find
Okay. So
tangent. We're just gonna have to work it out in our heads and then find out afterwards. But at least we've now solved what the sin W thing, what opposite really means.
equals CD and then
CD for hypotenuse.
Hypotenuse, and then DE for the adjacent.
Well, it's actually opposite here. Opposite.
Opposite. Yeah, for the opposite, and then.
But you've got them the wrong way around, have you not? Should DE not be on top of CD? Should it not be the other way around if hypotenuse goes under it?
Yeah.
Mm-hmm.
Okay. And then that equals $80 over 89.
Okay, let's now check it. So I'm going to share my screen again. 80 over 89. Share my screen. Hopefully.
I can't see the screen.
Let's see.
Okay, I can see it now.
So it's 80 over 89, we thought.
Yeah.
Because we followed the example. We find out with the opposite. So it was for C. So C opposite. Let's see. Oh, okay. So right. Okay. So this is we got the 80 right. Now it was 39. Now where did they get that 39? Right here. This is an important point here. See in our example that we looked at in the practice question.
Yeah.
Before we did the questions, I didn't see anything about tan here, but here they've given this is new material. So for tan, it's a slightly different you work it out slightly differently. Okay, so you might want to take note of this tan as well, because tan uses adjacent here. Tan does not use hypotenuse at all. We need to get these. We need to get these in our head. These formulas, because they're different.
Yeah.
Okay. So, could you read that out to me? So tan, the formula for the tangent of LC. C.
Okay. Tan equals opposite over adjacent equals DE over CE. Substitute opposite equals DE and adjacent equals CE equals 80 over 39. Plug in DE equals 80 and CE equals 39. So tan equals 80 over 39.
So for sin equals opposite over hypotenuse, and tan equals opposite over adjacent. So we need to remember that, the differences. So that's good. I mean, we're learning here. These things we will get them.
Yeah.
Just take time. We're not going to get it in one sitting.
Yeah.
Okay, are you happy to move on then?
Yeah.
Okay, let's move on. Right, we're back to sin. We're back to sin. Sin u. So, what I'm going to do, we'll do it like we've done before. I'm going to see if you can. So we're capture 1.6. Okay, so I'm going back to this whiteboard, and we're going to try it now. So let's delete everything. Mahdi, delete everything.
Okay.
Okay. Capture 1.6. Now you should hopefully. I've got high hopes for you. Now that we've done a few of these sins questions, you'll get this one, no problem. So sin u. So we walk me through it as well if you want. You can walk me through it because we've.
Okay, so what I would do here is sin and u equals is it
Mm-hmm.
and then equals u, then opposite u is okay, so u to t, is it u to t?
Okay, so the opposite of u. So the opposite of.
Oh,
Oh, it's a tricky one. So
is it v to t? Vt.
yes,
Okay. Vt and
that's
then
opposite. That's not that. Now I think you nearly got confused there because you thought VT was the hypotenuse, didn't you? For a minute.
yeah.
It wasn't. It's easy. I know. Look at that right angle. Hypotenuse is always opposite the right angle.
Oh, okay, yeah. I get it. Okay, so now it's u to t.
Mm-hmm.
That equals 13 over 12.
Hold on. No. It's the other way around.
Oh, okay.
No, the opposite is actually the 12.
Oh, okay.
So 12 over 13. Okay, let's see. I'm going to
Yeah.
share my screen again to see. So 12 over 13. Let's see how we did. Now, that was based on what we learned in the past there, in our past examples. So so it's 12 over 13 as a fraction. Let's see. 12 over 13. Let's see if we got this one. Good work. Well done. Maddie, are you ready for one more?
Yeah.
Okay, good. See, we're making progress now. So I'm snipping, save it again. Capture 1.7. Go back to the whiteboard. Delete everything for me. Maddie, delete this image.
Okay, done.
Thank you. And then, okay, uploading. We have another sin. So sin B. So find the sin of B. Okay, so the angle for
Okay.
fraction there. So it can be done as a proper fraction. Okay, so it's a fraction. Hopefully that so sin b. Yep.
Equals opposite news, and then that equals BC.
So the opposite of b is, remember, don't
Oh, okay.
the
Yeah.
opposite and the hypotenuse. So where's the hypotenuse in this?
CD. Is that
CD
CD?
for what?
For the opposite.
Okay. Yep.
And then for hypotenuse, it's CB.
Okay, so
So that equals, as it is, 15 over 17.
okay, 15 over 17. I'm going to share my screen again. 15 over 17. Screen share. Let's see, I'm going to 15 over 17 fraction, 15 over 17. Let's see, submit. Good work. Now, oh, this is one we have we done costs?
No.
Right, we need to do costs. Now, there is a chance we haven't done now, the fact is we haven't done costs yet, but do you want to, I'm just wondering, do you want to what do you want to do here? Do you want to see what the correct answer is, or
Could we just have a look at it so we get an idea of what it is, and so I could write it down?
yeah, so you want to see the answer?
Yeah.
Okay, let's see. I'm not going to submit an answer, but the correct answer is 8 over 17 in this case. So for cos, the cos of an angle in a right angle triangle is a ratio. So for cos, it is the length of the adjacent leg divided by the length of the hypotenuse. So cos x. Do you want to write the? Okay, so here it is.
Okay.
So we've looked at sin, we've looked at tan, and now cos. Do you want to read this out for me as well?
Yeah. So cos x equals adjacent over hypotenuse equals wx over xy. Substitute adj equals substitute adjacent equals wx and hypotenuse equals xy. Equals 32 over 68. Plug in wx equals 32 and xy equals 68. Equals 8 over 17. So cos equals 8 over 17.
Okay, so they've simplified it. Now, the adjacent to x, do you see the adjacent is actually the 32? It's not the 60. Adjacent to x,
Yeah.
and then the hypotenuse. We know. Okay, so I'll let you write that down, and then we'll get back to the questions.
What time will this lesson finish?
Very soon. Do you want to do a few one more question, or are you happy enough to keep going for 5 minutes?
Yeah, I could do 5 minutes.
So I'll just let you write this all down, and then we'll have a look at the question. Next question.
Yep, I just finished.
Okay, so all right, so we're just going to now look at the next question. So this is a sin. Okay, so off the top of your head, what now that we've worked through some examples, I think you'll be able to do this one in your head. So what do we know about sin? Sin is what? What can you can look back at your notes if you want.
So we do opposite over hypotenuse. So that means that opposite is 70, and then 74 is the lower number.
Hypotenuse.
Yeah.
You forgot to simplify it down.
Oh, okay.
Okay, you did get the 70 and 74, but you need to simplify it. Okay, so we'll continue on then. Okay, cos then.
Cos.
What do you know?
So it's adjacent over hypotenuse.
Okay, so what would it be in this case? Adjacent to G.
It'd be 36, but we'd have to simplify it, I think.
Okay, 36 over
hypotenuse 85.
Okay, and how can we simplify this down? Does it say simplify in working it out?
Yeah.
Okay, let's simplify it down then.
So we would do, so the top would be 6.
What are you dividing it by?
6. Okay. And then the bottom would be
so 85 divided by. Does it not go in?
Sorry?
You working it out?
Yeah. I think I did something wrong because I got a decimal.
Yeah, it needs to be a whole. It needs to be 36. Want to see what they've given us? Do you want to see what? Do you want to submit it?
Yeah.
You can't simplify it down to anything lower.
Oh, okay.
So that obviously okay. So that you got that one right. Well done. So sin again. What have we got?
So we do opposite over hypotenuse. So opposite is 24.
24.
And then the hypotenuse is 26.
Okay, and can we simplify it? Does it say simplify it? No.
Yeah, I think we can.
Okay. 2.
So I think the top would be 12.
Okay. Oh.
Actually, yeah, 12, and then the bottom would be 13.
12 and over 13. Well done. And okay, cos. What does it say for cos? What's for cos? The
So adjacent over hypotenuse. So the adjacent is 12, and hypotenuse is 20.
Okay. Can we?
Yeah. So it'd be 6 over 10, and then we could simplify it again. So it'd be 3 over 5.
3 over 5. Well done. And one more for tonight. Cos J.
So the adjacent would be 45.
Adjacent to J. Hold on. Adjacent is next to.
Oh no. It'd be 28.
Okay. Yep. 28.
And then the hypotenuse is 53.
Okay. And can we simplify it down?
No.
Okay. So it's cos equals adjacent divided by hypotenuse.
Adjacent over hypotenuse. Yeah.
Adjacent over hypotenuse. Fantastic. Okay, I'm happy. Hopefully you're happy with the progress we've made today. Now it was a big learning curve actually for both of us going over all that, but I think we managed to pull through in the end. I'm just going to delete.
Yeah.
Can you delete everything there? Are you able to delete all that?
Yeah.
So
done.
thank you again, Mahdi. I'd like to thank you very much. I do think that I'll be sharing. Are you happy if I share some of this lesson with?
Yeah.
Yeah,
Yeah.
online. I think we have made a lot of progress, and it was great doing that. Just I enjoyed your company, and I think you engaged very well again. And um, some of this you've probably already covered in class. Pythagoras' theorem, and you have covered trigonometry. But I think, do you understand it more? What? So if
Yeah.
I asked you, what did you learn today? Do you think? How would you answer that question?
So I learned the Pythagoras theorem and how to solve some equations with Pythagoras theorem, and then I learned sin, cos, and tan.
Mm-hmm. Sin, cos, and tan, and again, so I think we definitely can go away with their feeling better because we understand. But we'll pick it up again in our next lesson. And
Yeah.
when would you like to do the next lesson?
Um, Monday.
Monday at 7 o'clock.
Yeah. Yeah.
Okay, I'm happy with that. And do you want to also send me over some of your progress notes and topics that you're covering in maths, and
Yeah.
that'll get me.
Yeah.
Okay, so that I'm happy to leave it there. So I'll say goodbye to you then, Maddie, and have a nice
Yeah.
weekend.
Yeah. You too. Bye.
Bye.